Hello everyone, my name is Manvi Sharma and I am presenting my project titled Dynamic Memory Management Visualizer. This project demonstrates how an operating system manages memory efficiently using techniques like paging, segmentation, and virtual memory. It also simulates algorithms such as FIFO and LRU to show how page fault and page hit occurs. Through this, users can enter their own frame size and reference string and observe how pages are allocated, replaced, and managed in real time. The purpose of this project is to simplify complex memory management through interactive visualization. First, I will demonstrate paging using the FIFO algorithms to show page faults, and then I will use LRU to show page hits. So the input is frames are 3 and reference strings I am taking, and the algorithm will be FIFO. First, I am demonstrating the FIFO page algorithm to show page faults. In FIFO, the page that enters memory first is removed first. So the steps here are page 1 and page 2. When entry memory, the page fault will occur. And same in the case of page 3. And when we arrives at the page 4, memory is full, so page 1 is replaced and page fault will occur. This shows how FIFO can generate frequent page faults because the oldest page is replaced without considering recent uses. Now coming to LRU, the inputs will be frames 3 and the reference strings is being mentioned. So the algorithms I will be using here is LRU. Now I am demonstrating it how the page hits shows. In LRU, the least recently page is replaced. First 3 references log into the memory, page fault will be there. Reference 2 appears again, memory hit. Reference 1 page appears again, page hit will be there. This shows page hit occurs when a requested page is already present in memory, reducing page faults and improving efficiency. This demonstrates that LRU can perform better than FIFO by reducing unnecessary replacements. Now coming to segmentations, I have taken the input likes base is equals to 1000 and limit will be 420. In heap segment, base will be 1600 and limit will be 360. And in stack segment, I have taken the base 2200 and the limit will be 520 and offset will be 120. When I click the build layout, it is that where memory is divided into logical segments instead of fixed site pages. Now the core segment will store program instructions, heap segment will store dynamic data, and the stack segment stores function calls and local variables. So the formula will be physical address is equals to base address plus offset. So here the example I have chosen that base will be 1000 and offset will be 120. So the physical address will be 1120. Here the logical address is translated into a physical address using base plus offset. For the code segment 1000 plus 120 gives us the physical address that is 1120. This is how segmentation maps logical program paths into physical memory using separate base addresses. Now comes another part, that is virtual memory. Here I have taken the inputs like memory frames will be 3 and the reference strings is given. So now I am demonstrating the virtual memory using demand paging. Virtual memory allows the operating system to use the disk space as an extension of RAM when physical memory is full. Now the steps are like page 1 is loaded into RAM and page fault will be there. In page 2, when it is loaded, page fault again is there. And page 3 also it will be page fault. Now the available memory frames are full. So the page 2 is referred again and page hit will be there. Since page 2 is already present in the RAM, a page hit occurs. So page 4 arrives, memory is full, one page is replaced and page 4 is loaded from disk. Here the operating system swaps pages between disk and RAM. So now last but not the least, FIFO versus LRU comparison. When I have taken the inputs like frame is equals to 3 and reference string is being given, so now I am comparing these strings to evaluate their performance. Both algorithms run on identical input and comparison is based on page false and hit ratio. FIFO replaces the page that entered memory first, and LRU replaces the page that has not been used for the longest time. So when we will compare the FIFO false, FIFO hit ratio, LRU false and LRU hit ratio, winner will be according to interpretation. If an algorithm produces fewer page faults and a higher hit ratio, it performs better. Usually here LRU wins. In this comparison, LRU produces fewer page faults than FIFO. So LRU is better performing algorithm for this workload. Overall, this project gives memory allocation, page replacement, segmentation, virtual memory and algorithms, and to simplify operating system memory management concepts. Thank you.